Hi, I'm Dave Barker-Plummer from CSLI and the OpenProof project at Stanford University. This video is a short demonstration of the Openbox application, an application produced by our group and used to do research and investigate reasoning with different representations. When I launched the Openbox application, in this particular instance, you will see that the Openbox application immediately opens with a window. And if you're familiar with our Fitch application from the Language Proof and Logic courseware package, you'll recognize this as a proof environment. If you're not familiar with the Fitch application, you may have encountered other proof editing environments, and this is very similar. This is a proof editing environment in which there are steps, represented here with this question mark icon. You can add steps to the proof, create subproofs, end subproofs, and create new subproofs. Each of these steps in the proof may contain sentences. For example, if this contained tet A and this contained cube B, then I might be able to infer from this little subproof that cube A implies, tet A implies cube B. The sentence tet A implies cube B is because follows from this subproof using the rule of implication introduction, because this subproof demonstrates that cube B follows from tet A. Of course, it doesn't really demonstrate that at all. These steps don't check out, but if you wanted to complete the proof, you could do so. The thing I want you to notice for the purposes of this demonstration is that the Openbox has come up inside this with this proof environment inside it, and there are two things going on in this window. One is that there is a representation of the proof. The proof consists of a sequence of steps, each of which contains or could contain a first-order logic sentence. And then, of course, there are the first-order logic sentences themselves. In our research group, we're interested in the question of how we can do logical reasoning with things other than sentences, or things other than first-order sentences. For the purposes of other languages, for example, modal logics, reasoning with modal logics, which also have sentences as their representations, is very similar to reasoning with first-order sentences. They're just different kinds of sentential representations, just as we reason with English sentences on a day-to-day basis. More interestingly, though, is what happens when you have other kinds of representations, for example, diagrams. The Openbox application serves two roles in our research group. One is it forms the programmatic foundation of applications that we produce as part of our courseware packages, most notably Fitch, the proof editing environment from the Language Proof and Logic package, which looks very similar to, but not identical to, the screen that you see right now. And another role of the Openbox is to help us to investigate what it means to reason with representations other than first-order logic and similar sentential representations. It's the second question that I'm focusing on in this video and that we are demonstrating the uses of the Openbox for. When I launched the Openbox just a moment ago, I cheated a little bit. The Openbox itself doesn't know anything about first-order logic or about proofs. When it launches, it looks in a folder as it happens in the user's home directory, for components that it can load at launch time. And my components directory in my home directory currently contains these two jar files. These are files of Java code that are loaded into the Openbox application when the Openbox application starts. Imagine that I remove the fol bundle. The fol bundle is the part of the environment that we just saw that implements the first-order logic components. Now when I launch the Openbox application, we see something different. Because the Openbox application realizes now that it doesn't have a representation to include in the steps of the proof. It doesn't start a proof environment window. What it actually starts is this window that we call the inspector. And the inspector enables us to see what is currently loaded inside the Openbox. Inside the Openbox, we've currently loaded this proof component, and the proof component is actually loaded by that other jar file that I left in the components directory and that was loaded at runtime. And also some other components that are genuinely part of the Openbox itself. Even though we have no representation to include in the proof, we can restart the Openbox with this configuration and obtain a proof window. It looks a little bit like the one we just saw, except that most obviously the first order logic tools that used to live here in the window no longer exist. They weren't loaded this time because they were part of the FOL component. I can still edit and construct proofs by adding steps, adding subproofs, ending subproofs, citing previous steps, and so on. But each of these steps now have no information inside them. There's no representation about that we can use to represent information about the problem that we're trying to solve or the proof that we're trying to create. So this is the sense in which the Openbox is open. We have to plug in particular representations into the Openbox to construct an environment that we can use to reason with. We can go one step further and remove the proof bundle from my components directory. Now my components directory is completely empty, and when I launch the Openbox application now, you'll see something very similar. Again, we see the inspector window. This time the proof component is not being loaded because the proof component was loaded from that jar file that I previously showed you. And now it's actually impossible to restart the Openbox because there's no way of representing proofs in the Openbox. All that happens is you get another copy of the inspector window. It isn't necessary to include components in your components directory to get them loaded. I can simply drag the proof bundle onto the inspector window to get the proof bundle loaded. And now I'm back to the situation I was in a few minutes ago, where I can construct proofs, but I have no representation for information inside them. Or I can go all the way back to where I started and load the FOL bundle as well. And now when I restart the Openbox, I can construct proofs using rules like reiteration that are part of the toolkit, or the more familiar first order logic rules like conjunction elimination. So you can see that the Openbox gives us scope to be able to design new kinds of components that might represent information about problems that we are interested in reasoning about, and construct proofs whose content does not consist of sentences, first order or otherwise, but contains more exotic representations, for example diagrams. That'll be the subject of future videos.